Hello everyone, and welcome to another Mini Sky Tonight. So with the success of the solar system tour, I decided to take a look at some of the more prominent moons of our solar system. Now, there are several hundreds of moons, at least over 200 moons in our own solar system, but I just wanted to take a look at some of the more prominent ones, especially the ones that have been in the news lately and or have been of interest to astronomers. So up first on our tour is the closest celestial object to us, the moon, and the one that we're hoping to go to soon in the future. So basic information of our own moon. It's named after the Roman goddess Luna, hence we get the term lunar in many different aspects, but we get it from the Old English word mona or moneth, hence the word month, because the cycle of the moon is roughly about 29 and a half days, or close to 30 days. So hence why many of our months are 30 days, because they're based upon the cycle of the moon. But it's gone by different names as well. For example, it's gone by the term Selene, which was an ancient Greek name for the moon, hence where we get the term selenium, which was an element that was found on the moon. Artemis or Diana, it's been given the name of Hecate, and in China, it's given the name Chang'e. And of course, many holidays follow around the lunar cycle. So if you've ever looked at your calendar and wondered why certain holidays aren't just the same day every year and they bounce around every time of the year, like Easter or some of the different religious holidays, it's because they're based upon the cycle of the moon. Like why Chinese New Year is always in some different part of the month or the year, or why we have Easter at different parts of the time of the year. Well, because they're based upon the cycle of the moon, not because of the actual calendar year. So that is why there's the difference. And the image that you see right here, I thought it was just really cool. This is a picture of the Earth and moon as seen from Mercury. So you can even see those two little objects from the distant planet. So one orbit is roughly 27.3 days, but one day is 29 and a half days. So why the difference? Well, to go from one point in its orbit back all the way around to that point is 27.3 days. But since the Earth and the moon are moving in their orbit, it takes a little bit longer for it to get back to where it's a full day, where you see the sun in the exact same spot. So because the Earth and the moon are in orbit, you require just a little bit of a tweak to add to get the full day. So hence why 29 and a half days, we get our months. It's roughly around about 384,400 kilometers from Earth, so quite a big distance. In fact, one of my fun facts I always enjoy is that you can fit all the planets side by side in between the Earth and the moon. In fact, if you want to check out a video I did some amazing fun facts that could blow your mind about space. I'll leave a link up here for you to check it out. On the daytime side, it's roughly 260 degrees Fahrenheit. On the nighttime side, it's negative 280 degrees Fahrenheit. So it's incredibly hot and cold. That's why many of the astronauts that did go to the moon had to wear special suits so they can A, have air, B, they can withstand the hot temperatures of the daytime side of the moon. The moon is roughly around about 1/4 the size of the Earth. It's like comparing a baseball to a basketball. And astronomers believe that once the moon was a part of the Earth, that during the early formations of the Earth was actually bigger, and then it got smacked by something about the size of Mars, and a chunk of it broke off and started to form and went into orbit, creating our moon. It's negative 12.7 degrees magnitude, so it's incredibly bright in the sky when it's at full. And it's what is known as tidally locked, or it's in a synchronous orbit. What that means is we always see one side of the moon at all times. So when something is tidally locked, it means it rotates at the same rate as it revolves. So to kind of clarify those two terms, because I know those two terms are often tossed around a lot. Rotation and revolution are two different terms. To rotate means to turn about your own axis. So think of yourself being in a office chair, and you can spin around in the office chair. When you spin around, you are rotating about your own axis. You're rotating in the office chair. When you revolve around something, the center of the rotation is something else other than yourself. So think of it kind of like a Ferris wheel. You are revolving around the center of the Ferris wheel. You're not rotating in the Ferris wheel, because if you were rotating, you would just be turning around in a circle inside your little cart. You are revolving around the center of the Ferris wheel as you're going around. So those are the two distinct terms. But in the particular case of the moon, as it revolves around the Earth, it's also turning on its axis at the same rate, to where one side is always facing the Earth at all times. So hence why we always see one side of the moon with those dark patches all the time. And as you go to the moon, it's about 1/6 the gravity, so you feel much lighter. So hence why when you see videos of the astronauts as they're bouncing around on the surface of the moon, well, that's just because the surface gravity there is much less. And so you get a little bounce in your step, which made it easier for the astronauts because some of those suits were incredibly heavy. Now, every time we look up at the moon, sometimes we see the moon in different phases. Now, many people believe that, oh, the phases of the moon are created by the Earth's shadow casting on it, or there's a physical dark side and light side of the moon. That is not true at all. It's basically the moon's position, where it is with respect to the sun and the Earth. So when the moon is in a certain position, half of it is illuminated by the sun. But where it's located in its orbit and we're trying to look at it, we may get to see it when it's illuminated, we may not. So as you can see in this image here, depending upon where it's located and we're looking up at it, we get to see it in different phases by how much light is projected onto the moon and what we can see. So an easy experiment to do this is literally take a ball and put it on a stick, and then have a light source of some kind of like a lamp, and hold out the ball, which is your moon, and you represent the Earth. And as you turn the ball around your body, you get to see some of the different phases of the moon because of the light that is shining from the light source onto the ball, your imaginary moon. So by looking at this, you think, oh, well, the Earth's shadow does cross behind when you turn towards the back side. So shouldn't we see an eclipse every month? And sometimes the moon can cross in front of your light source. Why don't we have eclipses every month? Well, there's a little bit of a complication. Not only do you have the moon in certain positions that can block the light, but there's a bit of a tilt. So it's going up and down and back up again in its orbit. So sometimes, as you can see in the diagram below, the moon, with as far away as it is, and the Earth's shadow can only cover up to where that first E is in ecliptic plane, sometimes the moon can't even cross. It's only at certain points in time in its orbit when it's hitting what is known as the nodes, which you kind of can see it right here. So the point where the ecliptic plane and the moon's orbit cross one another, and the sun and the Earth and the moon are in that position. So you have the sun over here, the moon right there, and then there's the Earth. So it takes some precise timing. So hence why we don't have an eclipse every month. So hence why when you get to see them, they're incredibly rare to see. And since the moon is so much smaller than the Earth, solar eclipses, meaning that the sun is getting blocked out by the moon, are much more rare to see because you have to be in the right place at the right time, because the moon is so much smaller that it only blocks out a little portion of the Earth. Whereas in a lunar eclipse, many lunar eclipses cover a wider area because the shadow of the Earth, which is blocking the moon, is much bigger, and so therefore a good portion of the Earth can see the moon being eclipsed. So not only do you get to enjoy some eclipses once every 2 or 3 years, but you get every night, one of the fun things you do, what is known as Lunar Peridolia or Peridiola. And it's basically looking for perceived images in a moon or shapes in the moon. And you can see many different shapes. You get to see the obligatory man in the moon. There's a woman in the moon. There's a rabbit in the moon. There's a frog. There's a moose. There's a buffalo. There's a dragon. There's some hands and trees. I have seen a lot of diagrams of different shapes in the moon. And you know what? Go out, enjoy the moon, take a look at it. Tell me what shapes you see and draw it out. That's a fun game you can play with your family, is figuring out what things can you see in the moon. Just for fun. But looking at the surface of the moon, and yes, we did go to the moon. So I'm throwing that lunar conspiracy far out the window. We did go to the moon in 1969, and it was magnificent. In fact, Buzz Aldrin called the surface of the moon a magnificent desolation. It was void of a lot of stuff. It was quiet, and it was just it looked like an open desert practically. And it had this fine powder filled with the surface, filling the surface of the moon. It's basically regolith. The Apollo astronauts were nervous when they first started to land because they didn't know what the surface of the moon was going to be like, because they were afraid that either it would be this fine powder that they could sink into, it could be this hard rock, which would make it a harder landing. They didn't know. But fortunately, the regolith that covers the surface, this fine rocky powder, is due to micrometeorites. Basically, little tiny particles that ram into the Earth that they don't do a lot of damage, but over a course of time, all those little particles ramming into the soil over thousands and thousands of years have created the soil, rather than being a hard rock, into this fine powder. And of course, on the surface of the moon, they saw different features. They saw craters, highlands, lava flows, and many of the highlands are created by heavy craters that created these high surface areas. So the craters created the lowlands where you get the lava flows, and these quote unquote highlands are just basically the higher up areas that the craters didn't hit, or the meteorites didn't hit. So you got the lowlands, which have all the lava flows, and then you have the quote unquote highlands. The moon is thought to possibly have shrunk about 90 meters during its formation, and basically it cooled off. We see some unique features like some lines and stuff on the surface of the sun, basically cooling lines or shrinking lines. And also one of the unique things that they found in the last Apollo mission to the moon was orange soil, basically volcanic glass. And it's a unique type of glass that they didn't think would be on the surface of the moon. In fact, it's hoping in the future missions we're able to go back to the moon to explore this different type of material. So these are all the unique features that can be seen on the surface of the moon facing us. The other side of the moon, the far side of the moon, is much lighter and it has a few other craters, but we're mostly interested in what we can see for our side right now. These dark areas are what are known as maria, or Latin for the term seas, because they thought there were oceans on the surface of the moon. But in actuality, they're old lava flows. And the term M-A-R-E, or mare, is a single term for maria, or the ocean of that particular area. And of course, you have the Sea of Tranquility, or Mare Tranquillitatis, the Sea of Tranquility. That's where Apollo 11 landed. And many of the different structures that you can see here, like the bright objects, are different craters. The most prominent one is the one called Tycho, or Tycho. I've heard it pronounced two different ways, but it's the brightest crater on the surface of the moon. And you can see all these beautiful streaks that come from the crater itself. Those are what are known as ejecta lines. Basically, the lighter material, as the meteorite smacked into the moon, created this plume, and that plume spread out the material. So let's look into Maria. As I mentioned, it's Latin for the term seas. They're basically solid pools of ancient lava. And they're impact craters and possibly due to ancient volcanoes. And we know that they're possible sites of meteorites because we notice they're rich in iron. Compared to the rest of, like, say, for example, the highlands, the Maria are very rich in iron, which indicate maybe these areas got struck by iron meteorites. But one of the biggest features on the surface of the moon is the South Pole, and we're hoping to be able to explore the South Pole further in further future missions. It has the second largest crater in the solar system, where the first largest crater actually happens to be on Mars. But this is the second largest crater in the solar system. It's the Acatin Basin, and it's huge. It's 2,500 kilometers in diameter, just in diameter alone. And it's 8.2 kilometers deep. That it basically dwarfs the biggest crater here on Earth, which, if I recall correctly, in the United States, I think the biggest crater in the United States is the big crater in Arizona. And even the bigger crater here in the world, it still dwarfs it as well. I think that crater is off of the Yucatan Peninsula, if I'm not mistaken. The rim of the crater, basically, this crater is so deep, it created, quote unquote, this rim around the crater, which has been known as mountains because it just is this big, huge uplift around the edge. And they're known as the Leibniz Mountains. And this area was actually first visited by the Chinese in 2019 when they sent a probe down there, and they're hoping to be able to find different features as well as materials in this crater. In fact, they hinted that there's a possible detection of water. So the structure of our moon. It has a very small core, and it has some internal heating, but very little left. I mean, it's basically has no magnetic field because the moonquakes that the astronauts experienced during the Apollo missions was basically due from shrinkage because it was cooling off. So basically, it's a dead object practically. So it's starting to die off. And of course, this lovely celestial object has been visited by many, many, many spacecraft. And I'm just going to go over the ones that have been a success, because several missions were supposed to go to the moon and many of them failed. So I'm just going to talk about the ones that have been successes. You have the Metcha and Ranger spacecraft. Those were the ones to put something into orbit around the moon. The Zon and Luna spacecrafts were the first ones to basically start taking pictures, and as well as our lunar orbiters and the Surveyor spacecrafts. And then, of course, you have the Explorer 35, which is the possibility to be able to land, to do exploration to see if we could indeed land something on the surface of the moon. And then, of course, you finally had the Apollo missions to land something on the surface of the moon. And then you have the Hittin, the Clementine, and Lunar Prospector. The Lunar Prospector one was basically to take lunar soil samples and bring it back to Earth. And of course, other future visits, including Smart 1, Selene, the Chang'e missions, the Chandrayaan missions, LRO, Lacrosse, Ebb, Flow, and many, many other things, which are studying different aspects of our moon, including the detection of water, the radiation on the surface of the moon, in terms of craters, and much, much more. And of course, we did put quote unquote rovers on them. Basically, the PFS 1 and 2, basically these were cars to go onto the surface of the moon. And these were put in the later missions of the Apollo missions because they realized they had so much to do. And these were going to be the last two missions. So on Apollo 15 through 17, these were the last missions. They had to get it done. So they basically put these lunar rovers on the surface of the moon to be able to get from one place to another to take soil samples in areas that they couldn't possibly land. And of course, our future missions. We are still interested in our moon even after many years of exploring it. Ever since even the first Apollo missions, we hope to be able to send more to the moon to explore it, and who knows, maybe have a lunar habitat. You have Capstone, Photon, Mission 1, and of course, one of the cool ones that I'm looking forward to is the Artemis program, which is going to put the first woman on the moon. And a little bit of history for it that you may not realize, Apollo in Greek mythology was a twin. He had a twin sister named Artemis, and she was the goddess of the moon. So you basically have the twin sister mission. So hence why the first woman is going to be putting foot onto the moon. So basically it's a unique heritage step forward to basically include even women to explore our universe. So where can you see it? Currently right now, it's near the constellation Scorpius, the Scorpion, and not too far off from the star Spica. So if you look towards the south-southwest, you should be able to see the bright moon in a mostly gibbous phase. The best way to view it is with a pair of binoculars or a small telescope and look along the terminator line. It's the daytime-nighttime line. So you can take a look at that and see several different craters and looking at how deep even some of the smaller craters are. Although do be careful, it is a bright object, so you might be slightly, it's like looking at a bright light and staring at it for a long time and then trying to look into the dark. It's very difficult to transition from an incredibly bright source to then the darkness again. So you might get some what I like to call light blindness, meaning that you stare at a bright light and then all of a sudden you get the after vision of that bright light in your eyes, and it's very difficult to see beyond it. So that's the first step in our solar system tour, the moon solar system tour. If you have any questions or comments, leave it down in the comments below. If you have a topic you would love for me to cover over, leave it down in the comments as well. And until next time, stay safe, stay healthy, and as always, never stop learning.